All right, let's talk about chapter 10, exercise 10, the my integer class. Now, before we jump into this exercise, I want you guys to not think of this exercise as what's the point of making this class. Try to think of it as what's the point of the functions that we have here, because that's where the meat of this exercise here is at this fourth bullet point. With all these functions here, that is where you guys should shift your focus towards. And these ones down here too, as well as what the static and the constant functions do as well. Because this is a very abstract exercise, there really isn't a practical reason for why anyone would do this. It's just there to kind of test your knowledge on if you know how to create, static functions, constant functions, and it's just overall practice on classes and objects in general. So I don't want you guys to shift your thinking from what's the point of making this class to what is this exercise trying to teach me? And I'll go over all of that as well. But unlike the previous examples that we did before, where we kind of had an objective, like in the last video, we made a class called cat, and then we let the cat meow, we gave it a name, we gave it an age, and stuff like that. I mean, you can think of many reasons why someone would want to do that, right? But for this class, we're just making a class that holds like an integer, and then we call in a bunch of functions that kind of, return some type of value or attribute regarding the integer. It's not really the most productive use of classes, but it does show us how we can use, methods and stuff like that. So let's just hop in. So one thing that I always like to do whenever we start an exercise is I like to just read the whole thing in full and then break it down line by line, kind of like little mini exercises. That way I can know exactly what we're trying to do, but I can also limit our scope to more easier things so I don't get overwhelmed. And this is something that you guys should do too. So let's go together. The myInteger class. Design a class named myInteger. The class contains the followings: an integer data field named value that stores the int value represented by this object, a constructor that creates a myInteger object for the specified integer value, a constant get function that returns the integer value. Constant functions is even, is odd, is prime that return true if the value is even, odd, or prime, respectively. Static functions is even that holds in the int value, or is odd, or is prime that return true if the specified value is even, odd, or prime, respectively. Static functions is even that holds a constant myInteger reference value, is odd, is prime that return true if the specified value is even, odd, or prime, respectively. Constant functions equals and equals constant that holds a constant myInteger reference value that returns true if the value in the object is equal to the specified value. And then a static function, parse int, that holds in a reference value of a string that converts a string to an integer value. And then it says implement the class. Write a client program that tests all the functions in the class. So that was a lot, right? And this is why I say let's just get the whole thing, gobble it up. And then let's just, just get an idea of what's going to be happening. So we're going to make a class named myInteger. And then we're going to check if it's even, odd, or prime. We're going to check if it's even, odd, or prime again using static functions. And we're going to use it again using a pass by reference. And then just a whole lot of functions. It's a bit redundant, but for the most part, we're making a class with a bunch of methods. And then we're going to have to implement the class inside of our main function. So now that we have a general idea, let's limit the scope of our objectives here. Let's just go to the first line here. It says design a class named myInteger. If I just told you to do that, there would be no complaints, right? So let's just pretend that's all we have to do for now. All right, so here I just have a basic main function set up and we're using namespace std. So just note that. So we're not going to have to put, standard : string, just so you guys know. All right, so going back to our problem, right? We just want to design a class named myInteger. That's our objective right now. We don't even care about the rest of the stuff. Let's just get a class named myInteger down. So to do that, we'll type in class and capital M, capital I, myInteger, followed by a set of colons and a curly bracket. All right, that's mission accomplished. We designed a class named myInteger. Now it says the class contains the following. Let's go line by line. Slow and steady wins the race. So now it says an int data field named value that stores the integer value represented by this object. Now, generally, whenever we have data fields, we just want to put that private because 9 times out of 10, these exercises are going to ask you for a getter function. So that basically just tells us right away. And we read this a couple minutes ago that we're going to need a get function. So we definitely want to stick this under private. So we'll create a private section. And under that, we will have an integer named value. And we'll just declare that. So we have a data field that is private and it's holding in an integer called value. And I think that's all they wanted from us here, right? And it data field named value that stores integer value represented by this object. Yep. So now it says, okay, now create a constructor that creates a myInteger object for the specified integer value. Okay, cool. So we just got to make a constructor. So let's go outside of the private and create a public access modifier. And we will create a constructor. Now, if you guys remember, constructors are basically just functions that are named after the class. So in the same capitalization, we do myInteger, followed by a set of parentheses and curly brackets. Now, they didn't say anything about it being a no argument constructor, so I guess we can just pass in value here. And then just make sure that you tell the compiler that, hey, this value will be set equal to value. This basically tells the compiler that, hey, whenever someone calls the constructor and passes in a value, say like 1, 2, 3, just make sure that you assign the value that they pass in to the class attribute here. And it basically just allows us to go into the main function and create a myInteger, let's just say int1, and then inside we're going to pass in 1, 2, 3. Now the compiler knows, okay, cool. He's making an integer of the myInteger class, and they're passing in 1, 2, 3 as a value, just like they do here. So I'm going to make 1, 2, 3, 1, 2, 3 up here. That's basically all we're doing. Now, if you want, you can just name this new value, and then you won't have to do all the, this arrow stuff like that. This is how I like to do it, but I just want to show you guys both ways. So now what's happening is we have a constructor called myInteger that accepts an integer called new value, right? And now when you call in the constructor, 1, 2, 3 is the new value. So now we're telling the compiler, hey, this data field, set it to 1, 2, 3, aka the new value. So that's just another way of doing it, but we'll just keep it simple, or you guys just pick whatever you want. It doesn't matter. All right. Now going back to our problem here, now it says that we have to create a constant get function that returns the integer value. So the reason why we're doing this is because right now integer value is private, right? So if we go into our main function here and try to do int, well, we'll try to see out int1 value. We would expect 1, 2, 3, right? But as you can see here, we're already getting squiggly lines. And if we even try to run this code, it's going to give us an error. Yeah, it was somewhere in the debug console. I missed it, but we can't pass in the see out line here because this value is private right now. So we use a getter function so that we can return the value and that we can see it. So just like the problem asks, a constant get function that returns the integer value. So we just need a getter for a value. All right, fine. So we'll just do get value followed by a set of parentheses and curly brackets because it's just a function. And then we want to return an integer, right? So we'll make this an int function. Because usually, whenever you see a function, it's usually void, right? Because maybe we're not returning anything specific. But with getter is you're usually returning something. And in this case, we're returning an integer. So we'll just call this int get value. And then we just return value. But wait. Inside of our problem, didn't we say, hey, we wanted to make this get function constant? Yeah, we did. And the reason why we want to do that is because we don't want anyone coming into our code and let's say they, modify the value. Well, if they were to do that, they would probably do it before we return. But let's say someone wanted to modify the value and say 42069, right? And they wanted to prank you. Well, they would be able to do that, right? So I'm just going to show you guys an example. Here's what happens when you don't make your get function's constant, right? Let's say, okay, we have our get value, right? Now we can see, right? We can see our value. We passed in 1, 2, 3, so we're expecting 1, 2, 3. So let's see out int1 dot get value. Let's just call this function. And usually we would expect 1, 2, 3 because that is the value that we passed in when we called it our constructor, right? So let's run this. And we got pranked. We didn't get 1, 2, 3. We got 4, 26, 9. How do we prevent this get value from being modified by malicious, people, or maybe there's a lot of stuff going on in your code, and you don't want this to be modified at all. That's where const comes in. Now, adding the const keyword, and you can already see we're getting squiggly lines right here. Now the compiler is screaming at us because we're trying to change the value inside of a constant function. So we can just delete that. And now when we call in our get value function, we'll get the right value that we passed in, which is 1, 2, 3. So that is why we add the const keyword, because we want to promise that we will not change the value that the user passes in whenever we call this function. And we just make sure that we add this constant keyword to make sure that doesn't happen. So that was your introduction to constant functions. The rest should be easy. So let's go back to our problem here, and let's just take it step by step. So it says that the class needs constant functions is even, is odd, is prime that return true if the value is even, odd, or prime respectively. So let's just do is even first, because we're dealing with 3 functions right now. That's a little bit too much to chew on. I like to take it easy, just chill out on the slow lane. So let's just get a constant function is even going. So we're returning true or false. So I guess we can make this a Boolean function. And we know that we'll need a Boolean function because an integer can either be even or it can't be, true or false. Only 2 options. So we'll set up a Boolean function called is even, and just like always, parentheses, curly brackets. But remember, it's a constant function, so we'll put in constant here. And the reason why it's constant is because we don't want this function to modify the value. We're just checking whether or not it's even or not. So a very easy way to check if a integer is even or not is to modulus 2. Because if you remember, if we take an integer and modulus that by 2, we're either going to get 0 or a number that's greater than 0. So if it's equal to, if the integer modulus 2 is equal to 0, then it's even. But if it's equal to something that's greater than 0, then obviously it's odd. Because if there's a remainder after dividing by 2, then that number is not even. So let's just set this up. Seems like we're going to need some if statements in this. So let's see here. We'll do if value modulus 2 equal to 0, then we will return true. Because remember, this is a Boolean function, and we are returning either true or false. And then we'll just set up an else statement, and then we'll say, well, just return false, because if you modulus 2 and we don't get 0, then it's obviously an odd number. All right, so this is our is even function, or constant is even function, that gets the value, modulus it by 2, and checks if there is a remainder or not. And if there is no remainder, or if the value is equal to 0, both those conditions are exactly the same, then we will return true for is even. Else, it's good if there is a remainder at the modulus 2, then there's that's definitely an odd number, so we will return false. So let's just see out int1 here, and then we will pass in, we will call the is even argument. So remember, the value that we're evaluating right now is 1, 2, 3 because we created integer 1 and we assigned it the value 1, 2, 3. So let's run this code. And 1, 2, 3, that is an odd number, because if we modulus 1, 2, 3 by 2, then we will get a remainder. So let's run this. Okay, so we got 0 here, and that basically means false. But let's create a new line here, and let's just run this again so you guys can see it a little bit more clearly. Okay, So our get value function returns the value 1, 2, 3, and then is even returns 0, which means false. Now let's say if we passed in like an even number like 12, right? What will happen? Okay, so we passed in 12 for our value, constructed the integer. We got 12 here for seeing out the get value. And then when we see out the is even function, we return 1 for true because 12 is an even number. Once again, we make this a constant function because we don't want this function coming in and changing the value, right? Because if you try to do that, let's say, hey, value is now 300, haha. Well, we're going to get squiggly lines here. If this constant wasn't here, the compiler will say, yeah, that's fine, go right ahead. But we don't want that. So we put constant. Just reiterating that for you guys because that is the key part of this assignment here. So the next part of this problem is asking for a constant function is odd. Now, this is what I love about functions. I love them, love them, love them. Because whenever they ask you tedious, same old questions, you can literally just copy and paste and change a couple things around and get the same result. So we're making an is odd function, right? That's basically like asking if something is even, but we're just reversing the logic. So we'll change this to is odd. We'll add constant, and then we'll check if the value is if the value modulus 2 is 0, then we will turn false. Because that would mean that it is even. And then we return true else because that means that it is odd. What's up here? Let's see. Expected I'm missing a semicolon somewhere. Am I tripping? No, I think we're good. I think the compiler is just lying to me. It looks good. I didn't take a good look at it, but we don't even have the, let's see. Let's call it in. Let's see what happens. Where are we missing a semicolon? Are we? Boolean is odd. Blah 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 blah. Okay, wait. Did we close this? I think yeah, okay, that's my bad. We did not close this function. That is why. All right, there we go. So we make a Boolean function called is odd. We add the constant keyword to it so that no one can change the value. And then we check if value modulus 2 is equal to 0. If it is, then return false because it is even. Or else return true because that means that it is odd. So, okay, now I know for a fact that the compiler is lying to me. But let's just add a new line here and run this. Okay, 12. That's the value that we passed in for an integer. We see out get value that returns 12. Then we see out is even that returns true or 1, same thing. And then is odd that returns 0. Let's go back to passing in 1, 2, 3 as our argument for the constructor. And let's see what we get. It should be 1, 2, 3, 0, 1. 1, 2, 3, 0, 1. Awesome. So let's just go over what we did so far so you guys aren't losing track. We created a class named myInteger. We set up a private data field to store in an integer named value. Inside of our public section, we created a constructor of the same name because that's how constructors work. And then we pass in the value integer value. We made sure to tell the compiler that, hey, whatever value someone puts in when they're calling the constructor, assign that to the value up here. Then we created a constant get function that returns the value to be used in this first line here so that we can see what value the user passed in. Then we created a constant Boolean function called is even to check whether or not the value is even. And we did the same thing to check whether or not the value is odd. And we tested them down here. They either return 0 for false or 1 for true. Okay, so really quickly, I just want to go over what a prime number is. So prime numbers are numbers that are greater than 1 and not divisible evenly by anything other than itself. So, firstly, 1 is not a prime number because 1 is 1. It already dissatisfies the first um, condition here. Then we check that, 5 is a prime number because 5 divided by 2 is equal to 2 with a remainder of 1. 5 divided by 3 is equal to 1 with a remainder of 2. And then 5 divided by 4 is equal to 1 with a remainder of 1. So there's no number that is less than 5 that can evenly divide 5. So it is a prime number. However, 6 is not a prime number because 6 divided by 2 is already just 3 with a remainder of 0. It divides evenly with no remainders. This already dissatisfied the condition, but let's keep going. What about 6 divided by 3? Well, that's equal to 2 with a remainder of 0. All right, buddy, that's it. You're not a prime number. I don't even know why we second guessed. So basically, within our is prime function, we basically have to check if the value, and in this case, 1, 2, 3, first we have to check if it's greater than 1, and if it isn't, then we will return false. Then we have to check the value divided by all numbers up until we're just 1 short of the value. And then we have to see if dividing those will give us a remainder. And if not, then it is not a prime number. So it's a little bit wordy, but we can do it. So we're going to return either true or false once again. So this is a Boolean function. And then we'll call this is prime. We're going to get a set of parentheses and colon. And don't forget, this is a constant function because we don't want the value to be modified. We just want to examine it. So we put that constant keyword. And then remember, prime numbers are all numbers greater than 1, all right? So first we're going to check if the value is less than or equal to 1. So if value less than or equal to 1, then we will return false. Then if the value is greater than 1, we'll just move on to the next condition. And in this case, remember when I said that, because remember, we have to check every value that is less than the value that we pass in. In this case, we check 5 because we divide by 2, then we divide by 3, then we divide by 4. But for a number like 1, 2, 3, well, we're going to have to start by dividing by 1, and we have to start by dividing by 2, we have to start by dividing by 3, then we have to divide by 4, all the way up to 122. That is a bit crazy to write in code by hand, but we have a tool for that. We're going to have to use a for loop. So we're going to set up a for loop. So for index I, starting at 2, because remember, we want to just start by dividing by 2, and keep going until I is less than, and we'll do value divided by 2. Sorry, a little typo here. We want to make sure that we include a value divided by 2. And now there's actually a very good reason for why we're going up to value divided by 2. Now you may be thinking, wait, don't we have to iterate through every value until we're just 1 short of 5? I did say that. However, this is a very efficient way of utilizing the for loop. And here's the reason why we're doing this. Okay, so if you recall back to factors, right? Factors are basically any number that can evenly divide the number that you're looking for the factor of, right? So the factors of the number 2 are 1 and 2 because 1 evenly divides 2 and 2 evenly divides 2. That is why 2 is a prime number, because the only 2 numbers that evenly divide 2 are just 1 and the number itself. Similarly, why 5 is a prime number, because the only 2 factors of 5 are 1 and 5. Or you can reword that to say that the only 2 numbers that evenly divide 5 are 1 and 5 itself. The same with 37. 37 is a prime number because the 2 factors of 37 are 1 and 37. Now, 2 is the only even integer that is a prime number. The rest of the prime numbers are actually odd. For every prime number that is greater than 2, that prime number is odd. So we can actually use that condition to our advantage. So if you notice, for every odd integer, right? Let's just pick a random odd integer like 271, right? Oh, that was accidentally a prime number, so we'll do 273. So, okay, 273 is an odd integer, but it is not prime because it has a lot of factors here. If it had just if 1 and 273 were its only factors, then it would be a prime number. But it is not a prime number, it is just an odd integer. But if you notice, the second greatest factor of 273 is less than 273 divided by 2. And let's just pull out our calculator here and divide 273 by 2. And yeah, it is less than 91. I mean, it's greater than 91. So, what does this mean for us? This basically means that any number between 91 and 273 will always give us a remainder if we try to divide 273 by that number. So let's do it. Let's do 273 divided by, let's pick a number between 91 and 273. We'll just divide we'll divide by 92. And yeah, boom, we get a very big irrational number here. And the reason why is just because every odd integer, in this case 273, its second greatest factor will always be less than half of the number. So let's check another odd integer. Let's check 973. Hopefully that's not a prime number. Okay, it's not. I don't even have to pull out the calculator. We know that 139 is a less than, I mean, is yeah, 139 is less than 973 divided by 2. I don't think we have to check that. But you know what? Let's just do it just for clarity. Let's do 973 divided by 2. Is that going to be greater than 139? Yes. So this is actually a very great example. So let's go back to our code here. Remember, our stopping condition is I is less than or equal to the value divided by 2, right? Let's say that our value was 900 in this sense, right? And let's say we didn't have divided by 2. So let me just write that. So let's say the value was 932, right? This for loop would check every number from 2 to 932. That is just simply not efficient. Why do that when we have the proof in the pudding right here that the only divisible numbers are 1, 7, and 139? Instead of going through every single value between 2 and 973, we'll just stop at either 7 or whatever reason. For whatever reason, if we don't stop at 7, then we're definitely going to stop at 139. Because if we divide 973 by 7, we won't get a remainder. We'll get a whole number. So let's just do it. Boom. But like, let's say this was a really, really big number, right? And I don't know, maybe we get lucky here. Okay, let's just ignore these, right? Let's say we got a really big number here. And let's say the least factor was 943. We would have to iterate through all of those numbers. And it's just not efficient at all. So we would just have to divide this number by 2. And that way we can just iterate through only half the values. So I hope that makes sense for why we're checking for every value that is, divided by 2. But if you didn't quite get it, just know that it makes the code more efficient and we don't have to check every single value up to the value itself. We just have to check every single value up to half of that. So when we're checking if a number is prime, we're basically checking for even division. And we kind of sort of did that with our odd and even functions. So basically we want to modulus the value by I, which represents every value from 2 to the value divided by 2, and check if that is equal to 0. If it is equal to 0, that means that our value has a number between 2 and itself divided by 2 that will evenly divide, and we don't want that. So that means that it is not prime. So we will return false if that condition is satisfied. So inside of our for loop, we will create an if statement and we will check if the value modulus I, which represents a bunch of values that we're checking, then we will, getting ahead of myself. If the value modulus I is equal to 0, meaning that there is a number inside of these range of integers that can evenly divide our value that we pass in. If this is true, then we will return false here because that means that our value is not prime. Now, if we go through this entire if statement and for loop and we don't return false, then we'll just go outside of the function and return true. Because if this number, if value went through the entire for loop without being 1 and without, modulus I being evenly divisible, then it is definitely a prime number. And that is basically our prime number constant function created. So let's run 1, 2, 3 through our prime function. So we'll do is prime. I think we need an inline for this. So this is either going to get us a 0 or a 1. So I think we kind of already spoiled ourselves, right? I think I ran 1, 2, 3, do the factoring calculator. I don't have it. I'll bring it back up. Hold on. Do factoring calculator. And this is just so you guys can visualize what's going on here, right? So we'll do let's see, here it is. Okay. So the factors of 1, 2, 3 are 1. Okay, 1 is cool. 1 is fine. 1, 2, 3 is divisible by 3, so it is not a prime number. And that's basically what this for loop is doing, right? First, it checks 2. 2 isn't up here. Okay, we'll increment by 1 again. Now we're checking 3. So in this case, right, in this highlighted case here, I is equal to 3. And if we modulus 1, 2, 3 by I, which is 3 right now, we will get 0. And we can even pull up here. We'll do 1, 2, 3 modulus 3, and we get 0, as Google says. So we will return false. That is why we set that up like that, is so that we could check whether or not the number is prime. So we did spoil ourselves, but I want you guys to get the logic of what's going on here. So let's run this again, and we will get 1, 2, 3 for the get value. Is it even? False. It is not even because it's 1, 2, 3. If it's not even, then it's definitely odd. So that's set to 1 for true. And is it prime? We already said no. So it is set to 1. But let's see if the number 5 is prime. So in this case, we should get 0 for even, 1 for odd, and then 1 for prime. So let's see here. We can run this. So the number is 5. It is not even, but it is odd, and it is prime. All right, cool. So our constant is prime function is working correctly. And I don't think I have to reiterate why we put that constant keyword there. I think you guys already know by now. So let's just keep going. What is the next step in our problem? So we have all these functions here, and they return true if the values are even, prime, respectively. Cool. Now we need static functions is even, is odd, and is prime that return true if the specified value is even, odd, prime, blah, 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 respectively. So basically they're asking us to make the same functions, but we have to make them static. Okay, so the reason why they're asking us to make some static functions, and you'll see in a second, but essentially is basically because maybe we want to use these functions, but we want to pass in an integer, right? Maybe something that's just not of the class my integer. So let's say we had an integer x and we set that equal to like 34 for now. Let's just keep that in the back of our minds while we make these static functions. So they said they wanted even, odd, and prime, and they wanted to make that static and then pass in the value x. So I think we should just copy all of this. Like, it's the same things, the same logic. But these, they said these were static, right? So we have to change a couple things here. Let's fix the spacing on this. Let's see here. So we have blah, 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 blah. This needs to be back a little bit. I'm already losing it. Where is it? Oh man, don't tell me I messed up. Don't tell me I messed up this fucking. Right, here we go. All right, yeah, okay. So I basically just made copies of even, odd, and prime, and then we're gonna take off the constant keyword because they are no longer constant. We want to make these static. And now, whenever we make a function static, instead of putting const after the declaration here, like we usually did before, we just put static before the type. So before bool, we put static, and then do the same thing here. I think they're all Boolean, so let's do boom, 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 boom. Static here as well. Why are we getting errors? Okay, that's fine. So we're passing in integer x, and it's basically we got an error there because static functions can't be overloaded. We have to pass in a value. In this case, we're passing in an x. And then we just change, instead of evaluating value for the static functions, we're evaluating x. And I'll go over what we're doing here. But we're basically just making copies of the same functions we just created, but we're making them static. And instead of passing in an object, we're passing in a simple integer value. Okay, we change x there, we change x there, and then basically everywhere we change value, I mean everywhere where we had value, we change that to x because now we're evaluating x. Okay, so these are our constant functions. We have is even constant, is odd constant, is prime constant, and now we have static is even, static is odd, and static is prime. The major difference between these two is not that they're static or constant. That's a difference, but the biggest difference is that instead of passing in value from the object, we're passing in a regular integer, just like how we use other functions before. I think you guys use functions with arguments. That's basically what this is doing. And then we make this static because these functions are called irregardless of what's going on inside of the my integer function. So let me just give you guys an example. So we're going to make a new line character here. See out new line. And now we're going to print out the even, odd, prime values for our integer x here, which is 34. So we would call, let's see, what do we call it? Okay, so it's basically the same name, but we know the difference because we're not adding in the object whenever we call it. We're just calling in the function. So we'll do is even followed by x, and then is odd followed by x because that is the value we're passing in, and then is prime followed by x. And what's the error here? Identify. Oh, right. Sorry. So because these static functions are under the myInteger class, we still have to tell the compiler that, hey, I'm taking these functions from myInteger. And the way you do that is simply just copy the name and then you put colon colon. Name here, copy the name and colon colon. Copy the name here and colon colon. Now this is how you call class functions that are not related to the objects itself. Now you're really starting to see the difference between the functions we made here and the functions we made here, because these functions are part of the integer class, and these functions are part of the integer class as well. But because they are static, we can use them with any value we want. These are basically like utility functions that are not relative to what's going on with the objects, if that makes sense. So we have an integer x that is set equal to 34. We're going to call in the static function is even to evaluate whether or not 34 is even. We're going to evaluate whether or not 34 is odd, and we're going to check if it's prime. And if I remember correctly, yep, it's going to be 1 for this, 0 for this, and 0 for this. So let's just check the second set of numbers. Illegal instruction. Did I mess? What happened here? Where did I mess up? Close the bracket. This is, wait. Okay, so constant. Plus. Control. Oh, I accidentally deleted the return. Okay, here we go. Okay. I messed up this function. Sorry. Return true for this. Yeah. This didn't return anything. I accidentally deleted it when I was copying the functions, I think. So let's rerun this code and hopefully I fix that. Yep, there we go. So what's the issue here? Hold on. Oh, new line character. All right. Should be good now. All right. Wait, whoa. Oh, God. Yeah. Y'all gonna have to bear with me. We have to see out these. Sorry. We just called the function. Nothing actually happened. Usually I would cut this, but I like to add in the mistakes when we're doing exercises, just so you guys know that it happens to everybody. But we want to see out the return values of these functions. We don't want to simply just call them. So don't make that same mistake I did. Let's run this code again. Okay. So we didn't add any new lines, but we know that the first value here, which is 1, means that 34 is even, which is true. 34 is not odd, and 34 is not prime, which is why we got 0, 0. Let's add some new lines again. All right. So let's just run this again for clarity. Is 34 even? Yep. Is 34 odd? Nope. Is 34 prime? Nope. And let me add in another inline too here. Okay, so we got our static functions down. What else does this giant exercise want from us? So now it says we want static functions is even, odd, prime that return true, blah 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 blah. So basically the same functions again, but this time instead of passing in the just a random value, we're passing in a reference value to the object that we want. So that's basically it's very similar to the static functions that we made here, but instead of calling in the function or method like this, we're just gonna call in the function using a reference parameter. All right, so let's go back up to our functions here, and hopefully I can do it right this time. We're gonna copy all of these, and we're gonna paste them again. I'm just gonna give a lot of space. Hopefully we don't mess anything up. Okay. Let's see. Did we mess anything up? I think we good. I think we got it this time. I think everything is good. So we'll just fix the indentation here. I think that's right. That's right. That's right. So we have 3 more static functions, but this time we're going to pass in our object as a constant. So I'll pass in my integer and then reference. And let's change it here. And just like how we change x or value to x, we're going to change x to basically my integer as a reference value. So this is about where things get a little bit tricky, but try to stay with me here. And these functions, we're passing in not a value, not an integer, but we're passing in an object. Now we need to give this object a temporary name, just the same way we give integers and strings names. So let's just call this obj for object. Obj here, obj here, obj here. And because we're passing in an object, we can't just simply say if object modulus 2. That doesn't make any sense. How do you modulus 2 an object? Instead, we're going to utilize our get value function to get the integer of the object and assign that a variable. And that way we can evaluate whether or not the get value of an object is even, if it's odd, if it's prime. So this is what I mean. So we'll create an integer. Let's not say x again. Let's just say z this time. So we'll say int z is equal to obj.get value. Because remember, the get value function allows us to get the integer of an object. And in this case, we're using that function to assign it to z. Then we use z to evaluate whether or not it is odd. And then we can basically just do the same thing for the rest of these functions. The reason why we do this is because we're passing in an object. This function now knows what the object is, and it knows about the get value function. So it knows what get value is. This will be like an integer, and then we'll assign that to z. I hope that makes sense. It's important to remember that this is just one way to do a simple task. But it's important, this exercise is very tedious and it's very methodical because it's important to know all the ways that you can pass in, by reference, by value, pass in an object and stuff like that, getters and setters. It's literally just busy work so that you guys know how to do things. That's why I told you guys, don't think about why we're doing it, because literally there's many ways we can accomplish this, right? And we have like 3 of the same function for what? It's literally just practice so you guys know. But let's just go back to what we were doing. So right now it doesn't know what z is, so we have to create z. We'll do that just by copying this line of code here. And then we'll change this x to z again. And then we'll change this x to z. And then we'll change this x to z. And then we will make z a real thing in the world of is prime. And I think we covered all of our bases here. And now when we call this function, and I'm just gonna copy, I'll just copy this inline here actually. So now when we call this function, and I'm not gonna make the same mistake that I made when I was calling these functions. It's kind of similar because these are like static functions. So we see out, we put the name of the class, colon, then we call is prime, and we know the difference because instead of passing in just an integer like how we did up here, we're going to pass in our object. In this case, we're passing in int1. Then we can add a new line here. And basically it's the same thing. We're calling in my integer is even. Oh, I wish I did it like even, odd, prime, but it's fine. I was just picking whatever function popped up for me. But now we're going to call in odd. And this should basically give us the same values that we got when we passed in, when we called the methods directly through here. Well, these 3 technically. So, you know what? Yeah, let me rearrange it so that's the same way so that you guys can visualize. Let me just call even, odd, and then prime so that you guys can see. And let's just comment these out because we don't need them right now. And yeah. Okay, so here's what's happening. So we're calling in the function we're calling even, odd, prime using the methods that we created, the constant methods here, all the way at the top from the beginning. And then we're calling in the static methods for our object integer with the value of 5. So let's run this code and we should get the same exact things. All right, let's check. All right, so we have 0 for even, 1 for odd, and 1 for odd. Then we have, 1 for prime, sorry. Then we have 0 for even, 1 for odd, 1 for prime. And this checks out because we're passing in the same thing. We're just calling in the function for the object here. And then we're calling in the function for the object here. It's basically the same thing, just a different way of doing it. The difference here is, though, we're passing the object by reference. And in this one, we're passing in the object by value. And basically the difference here is passing by value makes a copy of the object, and passing by reference just points to the object. And explaining this would make the video way too long, but this is a good way to understand it. And we can just add this back in as well. And we can make a comment here and just say static functions for, I don't want to say irrelevant, I want to say non-instance variables. And when I mean non-instant variables, I mean variables that are not relative to the integer class. In this case, our x variable that is equal to 34 here. So we're almost done. It's a long haul, but we almost made it. Let's see what else we need for our exercise here. So now we need a constant function equals and equals const my integer that returns true if the value in the object is equal to the specified value. Okay, hold on. Let me see. Let me see what they're asking for here. Equals and equals that returns true if the value in the object is equal to the specified value. Oh, okay. I see exactly what they want. Okay. So they're basically asking for functions that are very similar. Well, not very, but they're kind of similar to the first three that we made. Remember how we were able to call them using the object with the, dot get value, blah, 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 blah. We're basically creating functions like that, but instead we're going to pass in a variable to check whether or not the integer and the variable is equal. That's basically all they're asking. And then we want another function that basically does the same thing, but instead we're passing in the object, if I am reading this correctly. Yeah, so we're passing in the object by reference. So let's start with the function that passes in the variable, because I feel like that's going to be easier. So it's a constant function, and we're going to be returning true or false. So we'll do bool equals parentheses. Don't forget that constant there because we're not modifying anything. And then we want to pass in an x. So we just want to see if the value of an object is equal to the value that we pass in here. So the very, very easy way to do that is to simply just say if value is equal to x, we will return true. And if it is not, then we will return false. And we can just put return false here. And let's test this. So we have an integer x is set to 34, and we have an object with a value of 5. So let's call in the function here. We will see out. Well, let's get a new line here, actually. We will see out a new line. Then we will see out int1 dot equals, and we will pass in x, which in this case it is 34. And basically this is a function that allows us to check if the value of int1 is equal to 34. In this case, x, which is 34. And obviously 5 is not equal to 34, so we should get 0 at the bottom of our program here for false. Yep. Now let's check. Maybe that was a fluke. Let's set the value equal to 34 and let's run this again. This should return true. And now it is 1. So yeah, that is our constant equals function that has a variable passed in. So basically we just got to do the same thing, but kind of like reverse. So we will make another equals function. And what is it? Constant, right? Or is it static? Okay, no, it's constant. Okay. So we're going to pass in the integer object this time. So pass in by reference. That's very important. And then within our curly brackets here, we will evaluate x and the object get value. My apologies, I read the prompt wrong. So apparently we're not evaluating, with this function, we're not evaluating a random variable and an object. We're actually evaluating the object that is in here and the object that we use to call the function. So I'll give you guys a very clear example of what I mean here. But basically we're passing in a new object, or two. We're passing in one object and we're using the object down here to call it. It's a little bit tricky, but you'll see what I mean. Just to give you guys a visual, let's go back to the simplest function, right? Whenever we made our getter function, right, we return the value, right? Because whatever the object that we put in front of here, like, int1 dot get value, like how we did down here, our function knows what the value of integer 1 is because we assign it with our constructor, right? So it's not much different with the logic that's going on in here. Whenever we call this function, it knows what value is, so long as we specify like how we do here. We do int1. So we're evaluating a new object with the object that we used to call the function. So we're going to evaluate value, and we have to make a new object. We have to, actually no, we don't have to make one. We already have one. So we just do object.getValue, and that is what we are evaluating. It's basically like the other equals, return true if equal, and then return false if not equal, obviously. So, okay, let's just go over this function a little bit because it is a little bit wonky, but try to stay with me here. So we have a function that returns true or false if equal or not. I think that part is simple. We're passing in a reference to an object, right? So we're passing in the object. All right, cool. The function now has the object. We're going to check if the value of the other object that we use to call it, like in this case, int1, and we're evaluating it with the object that we passed in. Right now, this object doesn't exist. We only have one object, but we'll utilize it in a second. So we're evaluating it with the object, and we get the value of it because like we don't know the value right now. So we use the getter function to get it. And then we return true if they are equal, return false if they are not. So let's utilize this. Let's create a new object. Let's create my integer. We'll do int2, and then let's do 20. Now let's call in our new function. And now I think this part is where it's going to start to make a lot more sense to you guys. So we'll do cout. And now, remember when I said we're calling in the method with the object? This is what I mean. So we'll do int1 equals. This tells the compiler, hey, I'm grabbing this equals here, not this one. And then we pass in the object. In this case, we're going to evaluate int1 and int2, so we have to pass in int2. And now, because of this line 189 here, it knows, hey, call in the equals function for the object int1, and then pass in the reference to object int2. And it's like, okay, int1's value is 34. We are comparing that with object get value for int2, which is 20. Is 34 equal to 20? Return true if yes, return false if no. So at the very end of our output here, we are expecting a 0 for false. And yep, we get false. Now, let's change this to 34 and see if we get true. And yeah, we get 1 for true. So, like I said, this is just another way of doing something. Like, if you guys can think of a different way of doing this, that's fine. That's great. This exercise is just a really tedious way of showing you guys how you can pass by reference, use getters and setters, and kind of just mix and match things. It's a very useful exercise, but in my opinion, I wish they did something a little bit more practical. But let's not smell the flowers just yet. There's still one more function that we have to do, and then we're free to go. So we have, last thing they want is a static function is even, oh wait, no, I'm reading that wrong. If we don't want that, we no more even odd prime. We just want a static function parse int that converts a string to an integer variable. Okay, that's easy. This is actually the easiest part of the program here, so we're finishing off easy. Let's just go here. We're passing in just a regular string. We're not passing in no objects this time. So we want to, I think this will be, this is the integer function, I think. So we'll just do int parse int, and then we're passing in a constant string variable. We're passing it by reference as well. and inside of parentheses. Now we're going to use a string function. The one that I like to use is s2i, which stands for string to integer. And basically, this is just a function where we can pass in a string that allows us to convert the string to a function. So we'll do s to I. And then we will return, actually, no, we just have to return s to I. Sorry. You'll see what I mean in a second. So we will return string to integer, and then we're passing in string. I didn't give the string a name. We'll do str. Okay. And then we got to put a semicolon there. So just to give you, like, I kind of blew through this, but it's a really simple function. So this returns an integer, because this will be turned into an integer. It's called parse int, and we're passing in a reference to a string called str. And inside of the function, we're using the s2i function. This stands for string to integer, really simple. And then we pass in this string here to turn into an integer. So let's go into our main function. We will see out a new line again. Then we will see out, and we're going to call in the function that is part of the myInteger class, and we're going to call in parse int. And let's create a string. So we want to change it into an integer, so obviously it has to be a string of numbers. So let's do string numbers, and then we'll set that equal to a string 1, 2, 3, 4, 5. Remember, this is a string literal of numbers. Like this is not the numbers 1, 2, 3, 4, 5. This is just the word 1, 2, 3, 4, 5. So we're gonna pass in numbers to our parse int function. So we'll just do numbers. Put a semicolon here. And what's the issue here? A non-static member reference must be relative to a specific object. Okay, I completely forgot to make this a static function. That is completely my fault, and that is why we got that error there, and that should fix that. While we're on the topic, I also forgot to make this a constant function, so make sure you put constant after this reference parameter function that we made. And let me just make sure it's static, const, static. Yeah, I think we got all of our bases here. Yeah. Okay, cool. I just forgot to make these functions static and constant. That's my bad. It's a very long problem, so we're prone to make mistakes. But now we can see out integers. And just so you guys know that I'm not joshing you here, just so you guys know that I definitely am changing the string numbers into an integer. We're also going to see out. We're gonna see out. Actually, we should do this in the function, right? Yeah, let's do that in the function. I wanna add the new integer so that you guys know. So first I'll show you guys how this works. It's kind of ambiguous because I mean it's gonna return 1, 2, 3, 4, 5 regardless if it worked or not. But just so you guys know, you see here, this is now an integer. This is no longer the string 1, 2, 3, 4, 5, but it's just the integer 1, 2, 3, 4, 5. But in order to prove that, instead of returning just the number, we will add an integer, just a raw integer like 23. Now, if we did this with an actual string, we'll actually get an error because you can't add words and numbers, but you can add integers together. And this should work if this adds together. And we shouldn't get 1, 2, 3, 4, 5, but something like, well, it would be 1, 2, 3, 6, 8. If my math is correct. Yep, 1, 2, 3, 6, 8. So that's just me proving to you guys that it's actually an integer. And yeah, that is basically this whole thing in a nutshell. Now you guys still need to implement the class and write a program that tests all the functions. We basically did that here, but I would say, put in some words in between, say that, hey, the value for integer 1 is this, integer 1 is even, you know what I'm saying? Just make it look pretty so we're not just, returning a bunch of zeros and ones. But regardless, anyone can look at this and pretty much tell what's going on here. Just to go over this long file we have here, We created a class named myInteger. We created a private section with the integer value as our data set. Inside of the public, we have a bunch of functions. We have our constructor, we have a getter, we have a boolean to check if it's even, odd, or prime. Then we have static functions for doing the same exact thing, but for a random variable outside of the class. Then we have static functions for even, odd, prime for a reference to an object. Then we have constant functions for a random variable outside of the class that checks if it is equal to an object. Then we have a constant variable that checks for two objects using a reference to a new object. And then we have a static function here that basically just converts a string to a number. And that is all part of the myInteger class. And the reason why we did that is so that we could show you guys how to call in functions, static functions, basically by doing class name, colon, colon, and then function name, and then whatever arguments or parameters you have. And that's basically the exercise for 10.10. I will post this code in the comment section below for your modification, and I will see you guys in the next one.